You could see the complexity of this surface. This surface can be part of your design while you make the pattern of layers. You can go for gyroid structures. That gives you a better performances. These kind of lattice structures are part of your design principles so that you can achieve certain better performances. Okay. I hope I'm going to stop this presentation in next few slides. So right now we have seen design principles, design for additive manufacturing techniques, different types of additive manufacturing processes. So what is the benefits we are going to get? So the benefits are, even if it is a complex geometry, you will be able to make it to market faster, and prototyping cycle will be lesser. Product validation can be done, functional prototyping can be done, and your concepts can be explored in a better way. So what is the scope for research in these areas? So as many of us are working on this additive manufacturing over the years, so we can work on integration of various aspects here. So material development is one of the important area, and evaluation of that. We talk about PLA and some of the powders. So we have to go for some new material developments specifically for additive manufacturing, and there should be some specific design methodologies. We talk about design for additive manufacturing, manufacturing for design principles. So we need to have some standardized methods, and a monitoring and control of this process has to be done, because if the layer um, thickness, if it is not maintained, then you will be ending up at a wrong product. So monitoring is also important. Characterization and certification of the product has to be done. So these are all four essential pillars, so that you can make a viable additive manufacturing process. So in these areas, still the researches are going on, and I hope you can take this one to explore in these areas: materials, design, modeling, and sensing and control. And there are certain standards. We talk about standardization of these things, because anyone can develop some design models and they can make a printing of it, whether it is readily approved or certified to be used in the standard applications. So there are certain standards coming up. So these are all some list of standards related to additive manufacturing. So we need to adapt these standards: ISO 1 to 100, safety of machines, risk assessments, like laser. We are using laser, so here we need to adapt EN 60851 standard, so that you make standard parts. Okay, so I hope I'm going to stop here with this final slide. So I would like to conclude like this. 3D printing is continuing to grow at a very high pace. It is estimated that there is a 46 billion opportunities are available by the report, Wohler's report. And there are many instances. There is a knowledge gap in designing and printing, so we should improve our skill set to use this design for additive manufacturing principles. And this slide shows, here you could see where we can go for further research. So as we know that we start with the digital model and end up with the final final product, there are certain uncertainties in the input materials and the equipments. So to manage that, we can use some uh, digital twins, digital threads to connect all these aspects. You can connect, you can adapt a process modeling technique and characterize the material. Through in situ process monitoring, you will be able to manage the final performance, because at every stage there are issues in the process itself. So we have certain opportunities to research in any of these domains to make this additive manufacturing a successful one. So I hope I have given you some ideas. I'm stopping here with the want of time. If you have any queries, you can raise now. Thank you very much for giving me this opportunity. Thank you all.
Good afternoon, sir.
Thank you.
Hello.
Sir. Yeah, yes, sir. Thank you, sir.
What kind of research that is going on at our additive manufacturing lab at VIT, sir? May I know what is the equipment that is available?
Sir, here we have metal additive manufacturing. We have varieties of machines. We are exploring automotive applications and aerospace applications. Researchers are working on product development and then testing it and verification and validation, modeling. So, as I mentioned, there are many challenges in making the final product, which may not meet your final requirement. So, how do we optimize this process and how do we improve it to meet the requirements? That's a kind of research which is going on.
Okay, sir. Thank you.
Thank you.
Hi, sir.
Hello, sir.
Hi, sir. Dr. Lakshman from Ramco Institute of Technology, sir.
Hello, sir. Yes, sir.
Sir, during the time of metal additive fabrication by using laser,
Yeah.
when I use aluminum-based materials, it will create reflectivity problems.
Yes, sir.
How
Yeah.
can you manage this problem, sir?
Uh, Sir, I am unable to answer this question at this point. I am mainly focusing on the control system side.
Okay.
Material side, I am not sure about it. I think any material experts can answer this. Aluminum based powders right now also we are using, but I think the laser power we can optimize and then we can reduce the reflectivity, but it may result in reduced melting.
Okay.
So where we can reduce the diameter of the laser, then the process can be optimized.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you, sir.
So is there any facility for testing in metal additive fabrication at VIT?
Sir, we have X-ray tomography system. We have, sir. After printing, we can go for non-destructive evaluation of these structures. Any cracks or internal cracks which might have been formed by these kind of layer by layer process, because the top layer will be hot and while the bottom layer will be cold, so there can be some residual stresses, and because of that joints there will be some cracks. So we have certain non-destructive evaluation machines are available. X-ray tomography is available. Using that, we can analyze that, sir.
Can we do some texture-oriented fabrication at metal additive, sir?
Yes, sir. We can engineer the texture as well, because as we have all flexibility of our design, and the manufacturing can be controlled to meet our texture, which can be done.
By confirming that through EBST or analysis, we can confirm what type of texture generated during fabrication.
Yes, sir. Yes, sir. That can be done. That can be done.
Thank you, sir. Thank you for
Thank you, sir.
answering.
Thank you, sir. Yes.
Participants, if there is any doubt, please clarify. There is any doubt, please clarify. Dennis sir, is it audible? Thank you very much for the nice presentation, sir.
Thank you, Balaji, sir. Thank you for giving me this opportunity. Thank you all.
Thank you, sir.
Thank you all. Thank you all. Bye, sir. Thank you.
You may leave, sir.
Fine, sir. Okay.
YouTube link also you have to say.
Dear participants, link is available in the chat box. Please fill it. the next session is on 3:30. So join at the time. Our YouTube link. Go to the YouTube link, and there is a feedback link also. That YouTube through YouTube link also.
முடிச்சிடலாமா சார்?